Okie dokie. So first of all, Dan, thanks for having us here. Multi-cloud is obviously something which resonates quite well with SAP and the large portfolio of applications that we have. I mean, given the customer base that we have, which is all over the place. I mean, pretty much if there is any infrastructure provider, some of our customers uses it. I mean, that's given, which puts us in this awkward situation to be in the middle and try to figure out how to provide best possible quality of service, regardless of where our customer base expects to get that in. That position is not new. I mean, we've been in that situation starting from the old on-prem times of SAP. When I joined SAP back in 2000, which was roughly 20 years ago, I was totally sure that that's going to be a temporary gig. And back then, I was super amazed to see how we are providing on-prem software in AS390, in AIX, in Solaris, in Windows, in Linux, in pretty much any platform out there, which pushed us into some awkward situations to evaluate and stretch the norms. Back at the time, it was about Java, and the notion of Java of write once, run everywhere. And actually figuring out that that everywhere is, everywhere where your current JVM implementation actually runs, not really everywhere. Which got us to a state that we had to actually license Java Virtual Machine from Sun back at the time, and implement something which we called back then SAP JVM, which we subsequently open sourced, contributed back to OpenJDK once the whole Java platform became open source, and now all of our ports to all the IBM platforms and the like are currently there. So we do have our own, therefore, SAP machine implementation, which gives us this same experience everywhere. So why is it important? Because if you don't have the same experience everywhere, then every time you get a ticket, every time you get a customer complaint or issue and a problem, then you need to first look into, okay, so where I'm running now. Am I running on Linux? Am I running on Solaris? And then you need to take the respective cheat sheet there for Linux or Solaris or Windows and so on. So 20 years forward in time, I mean, if you think of multi-cloud and the hyperscaler era, we have the exact same story. We're just not talking about the on-prem platforms with Solaris and Linux and Windows and AIX and so on. We're just talking Amazon, Google, Azure, Ali Cloud, Packet Cloud, and so on. So therefore, some motivation there about Gartner and how it comes in place and how does it play in that space. So first of all, why Kubernetes? Internally, we discussed, we had a bunch of different ideas how we can come to this coherent layer, which allows us to optimize our operations, optimize deployment, delivery of software, and so on. And then Kubernetes naturally came to mind as the layer to facilitate that. Many products on the SAP portfolio are currently based on Kubernetes under the hood. I mean, of course, that's of very little interest to the customers on top using them, because to many of those customers, they actually don't even notice Kubernetes, and they shouldn't. I mean, it's none of their business how we optimize our underlying infrastructure operations, but it is underneath, and it is providing the value. So if you look into how things started, and I mean, for me, basically time starts in 2000. Before that, I was young and naive and still in school. So all of those challenges were kind of far distant, and I didn't really care much. I was more into gaming. But from then on, we had all these kind of challenges with virtualized, non-virtualized hardware, infrastructure as a service with Amazon in the early days, and so on, until we reached to the point of the foundation of the Cloud Native Computing Foundation, where Kubernetes was kind of defined and was the first project of. And afterwards, there was kind of a Cambrian explosion of innovation. You know, with Istio, with Knative coming in, we've been involved in both. And obviously on our own, we also have open source projects that are playing in the same space and are filling gaps. We do not really push them a lot out there in terms of customers, because SAP is predominantly a business application company. So we are not into we're not Red Hat basically. But at the same time, we firmly believe in the value of open source. We firmly believe that this is the way to collaborate, and it has massive benefit for everybody involved, including SAP. Therefore, we are fully behind the open source story there. A few projects I wanted to mention here. One is Gardener, which we're going to look into much more details. Another one is Garden Linux, and we're going to talk about that as well. And last but not least is Schema, which is our extensibility in a box kind of layer on top, which we put next to each of the products in the SAP portfolio, allowing people to deploy code next to that. So if you look at Gardener, what is the challenge? So Kubernetes is out there, right? Anybody can take it, anybody can deploy it, anybody can run it. There is managed Kubernetes in every hyperscaler. So what's the fuzz about it? Well, the fuzz about it is that, like with Java in the past, where there was hotspot implementation from Sun, and then there was an IBM implementation from IBM, technically they complied to the same Java language specification, but the moment that you started using files, or you started using sockets, or you started, dealing with specifics of memory management and garbage collection, then immediately you've hit the wall of how is the different behavior of Java impacting your applications. And if you have like large application stacks, like we did back at the time, and we still do, then very quickly you find out that the write once, run everywhere promise is very thin and very narrow in terms of the consistency that you get across the different places that you run in. So Kubernetes is not different here. So yes, there are, technically speaking, Kubernetes managed services in every hyperscaler, but they behave widely differently. In terms of version support, which is widely varying across the providers, in terms of how do those distributions behave in terms of high availability deployment, cross availability zone deployment, behavior when underlying resources start disappearing because of outages or because of conscious or unconscious actions by the operators underneath, in terms of memory, memory horizontal, vertical scaling of the clusters, and in terms of network throughput and network resilience. So the moment that you start deploying your application through those different services, you very quickly find out the differences on those, and then you are back into the old days that we had with Java, where depending on where you have an issue right now, I mean, as Jonathan outlined there, if one of the providers that you're running on in your assist has an issue, then basically you need to take out the cheat sheet for that particular provider and start hammering there the challenges that you faced. So Gardener, in that sense, aims to provide homogeneous, completely configurable, and completely consistent Kubernetes across all the infrastructures that it runs with. It's all the implementation there is based on standard resources like VMs and the low-level networks and VPCs that respective providers offer. We run currently thousands of clusters on top of that. So within SAP internally, we run that ourselves. But there are also external companies that have taken Gardener, wrapped it, white labeled it, and are providing currently managed Kubernetes as a service to their own customers. So in a sense, it's not an experiment that we're just playing with and try to see whether it works. I mean, we're really betting on that in terms of running Kubernetes at scale for many of our commercial offerings. We manage fleets of clusters here, and that goes to multiple dimensions in terms of data centers and infrastructures, in terms of products, in terms of development, validation, and production, in terms of markets. I mean, Jonathan as well mentioned the challenge with regulated markets and geographies where there is simply no hyperscalers that you can run on. Yeah, well, surprise, surprise, SAP also has to serve customers in those regions as well. So that's where Gardener comes at play. At the moment,
sorry to interrupt you. Someone is trying to get into the meeting, and since you're the host,
of course I will. Just give me a second.
Apologies. I didn't mean to throw you off. I saw a post on
participants.
The meetup.
As soon as I manage to find the.
Why don't I can just reclaim host, and then I'll take care of it there. And I think your share is still working, right?
I think
yeah,
so.
The share is still there.
Okay, cool, awesome. Sorry to interrupt everybody.
Even better, no worries. Cool. So if you look at like one double click below, the whole thing is about like the homogeneous setup and making sure that you get the exact same version of Kubernetes whenever there is a new version of Kubernetes. At the very same point of time, you can get it on Google, on Azure, on Amazon, on Ali Cloud, on-prem. You can do that because basically the orchestration layer around managing your clusters is supporting that version. If you try to do the same or achieve the same with the managed Kubernetes versions out offerings out there, you're going to have a challenge because they do have different different horizon of versions that they support, different adoption timelines there after a new version of Kubernetes is released. Pretty much none of them offers support of experimental features, alpha features in control plane and so on. So all of those are things that are out of your reach if you're running on a managed Kubernetes service out there. On-premise and hyperscalers, that's definitely in scope for us. Efficiently managing thousands of clusters too. Day one and setting up a cluster is one story. Of course, then logically, next question is, okay, what do you do after? How do you upgrade a cluster? How do you deploy additional components on the cluster? How do you update them afterwards? How do you update the operating system underneath? You know, all of those are things that we have to deal with. The move from CoreOS to no CoreOS is obviously a pain in the neck for us, and I mean for pretty much everybody out there. So we had to deal with that. This is where on our side Garden Linux was born, which is a distribution that we are maintaining ourselves, which serves as a one-to-one replacement for CoreOS. It's also open source, so completely available out there, and it's slowly growing into being the most adopted container OS that's used internally on our end. Support for older versions is critical because we cannot really rely that we can consistently push all the products on our side to a next version of Kubernetes because there is a newer version of Kubernetes out there. So we definitely do have a long tail that we have to deal with. But also for those products that are much more forward-looking, supporting the latest version of Kubernetes with all the alpha features in there is also critical. And that's a horizon which we didn't find with any provider out there. And then last but not least, compliance requirements. So we also need to deal with compliance requirements to the different products. And we have another project which is called Caridia, which is doing compliance validation there for cluster configuration and the workloads on top. So if you look at Gartner, very quickly through that, if you think of a typical Kubernetes setup, that's what you think of, right? I mean, you do have a control plane for which you, of course, have at least minimum 3 instances for high availability, and then you have the workloads which are running in there. So that's what you would imagine having out there. That's kind of the norm. I mean, if you're setting up Kubernetes, that's what you're going to end up with. The control planes are obviously highly underutilized, but super critical and essential to be there. Nevertheless, that's a decent tax that you have to pay for, the benefit of running Kubernetes. So Gartner approaches that a little bit different. So we do have something which is called a seed cluster, which is a Kubernetes cluster itself, which has its own control plane and then a bunch of worker nodes. But actually, the worker nodes there are representing the control planes for the other part of the clusters. So then this leaves the remaining, as we call them, shoot or offshoot clusters. The content that runs in there is basically just the workload. So no tags, no control plane, no overhead. So all of that we have taken over, and we're running centrally in the seed cluster of Gartner. So this includes etcd, the API server, and you can scale and manage that accordingly. So this essentially, in the Kubernetes world, this is called Cubeception, where you're running Kubernetes on Kubernetes. We are doing that since 2017, so nothing really freshly new or experimental. So that was an idea we had in the early days, and over time it matured a lot. I could safely claim that for some of the cloud providers currently, we do have better support in terms of stability and resilience than the respective native Kubernetes offering on the cloud provider. Because on our side, experience is key. So we need to make sure that clusters are consistently resizing, upsizing, downsizing, updating, and so on. Therefore, we do have remediation controllers there, which are workarounding, let me put it that way, certain deficiencies of the cloud provider infrastructure that we face here and there. And we can do that because it happens once in Gardener, so that all the products on top do not have to deal with that. So as Dan said in the beginning, running Kubernetes across all hyperscalers is a challenge. Actually, the majority of the products that we're dealing with do not necessarily see it as a challenge. And we're going to see in a second, why I think so. So if you look at the bigger landscape perspective, I mean, there is something which we call Garden Cluster, which we run ourselves, which is then managing the different seed clusters, out of which we run multiple in different hyperscaler regions, which on their turn are managing the shoot clusters, which are typically local or nearby, running in the same or nearby region there in a hyperscaler. So that's how things work. So there is currently no way for shoot clusters to connect directly back to the Garden cluster. So there is a pretty strict flow of configuration, flow of control, flow of credentials. So that's pretty well structured and pretty efficient these days. In terms of latency, when I'm saying we have a seed cluster running in the same region or a nearby region, typically, like low latency there is key because the different node managers, they have certain latency requirements towards the control plane. While the seed cluster doesn't need to do a lot of chit chat with the Garden cluster. Therefore, we can tolerate their high network latency, which gives us also a chance to run the same setup also on premise, where we do have a seed and then a bunch of shoots running, let's say, on vSphere. And then the seed every now and then, reporting back metrics and health status back to the Garden cluster. So if we look at demo time, of course I didn't want to just run, PowerPoint karaoke. That's why I thought I'd just get you to something more real. So if you go to gardener.cloud, that's basically the project page. Out of here, you can reach to pretty much all the different assets, including GitHub, the documentation, list of the adopters. I mean, I mentioned them. There are a bunch of companies that are taking currently Gardener, SAP obviously being the first one, but a bunch of others who are white labeling that and using it under the hood. T-System being a very prominent example here. So if you look at Gardener, you can get into all the details here in terms of version support for Kubernetes. Pretty much everything that I explained so far explained in much more depth and with much more examples. We provide obviously a certified Kubernetes installations, which are passing successfully the Kubernetes compatibility test kit. That's part of our regular output qualification, so nothing goes on without being properly tested and validated. So when you log into to something which is called the Gardener dashboard, it's a web console which gives you access to virtual projects. So a project basically, and in that particular instance, I only have one that I created for the session today. In there, you manage a bunch of different aspects. You manage members. So, I mean, I can, let's say, invite somebody here like Dan or Pavel, I mean, that goes through emails. So I can add other people who are going to work together with me. What's that on top? CoreOS. Okay, yeah. CoreOS reached the end of life. Therefore, as I mentioned, that's pain in the neck. So we had to somehow get certain clusters out of CoreOS into some alternative option. And we do have few alternatives in place. But that's, yeah, well, it is whatever it is, we have to get over it. So in here, I can manage the people that have access to that project. Think of it as a bucket where clusters are managed. I can manage secrets for different infrastructures. So for that particular landscape that I'm running on here, we enabled support for AWS, Azure, Google, OpenStack, and Alibaba. And I have trial secrets there bound for AWS, Google, and Alibaba. For OpenStack and Azure, I don't have any secrets in place. If I had some, then I would be able to create clusters there too. If I look at clusters, which I freshly created today in the afternoon, I do have one in AWS and one in Europe. The version of Kubernetes here is, I mean, the one that I created in AWS. I created second, and then I actually figured out that there newer version of Kubernetes that's out there, 1.19.6. The default one that we currently recommend to people is 1.19.4. 0.6 is still experimental. If I want to take a cluster and actually update it to a new version, it's pretty much as easy as that. And then behind the scenes, currently, like the upgrade will take place, and in a rolling fashion, it will update all the nodes. Just let's just take a look at one of those clusters. So if you look at the one at AWS currently, it has a name which is something representable for me. AWS test January 8. It will terminate in 7 days, and that's how I configured it in the beginning. Kubernetes version. I do have worker groups in here, which I can configure. I can have different worker pools for different types of workloads. Then having their tagging there for workloads would allow them to be scheduled on the respective worker pool. It was created by me. Purpose for me is evaluation. So we do have certain tagging for clusters here, which enables then operations teams to better handle, when you go beyond the handful of clusters that you typically run, and then you go into the hundreds and thousands, then you need some criteria there to figure out whether something is critical or not. I mean, if you have an evaluation cluster, having issues, then typically you don't wake up in the middle of the night. If it's a production cluster, you will definitely wake up in the middle of the night and do the necessary to get it up and running. There are some certain SLAs which are internal for that particular case, so not much of an interest. The Kubernetes dashboard I didn't deploy, therefore that wouldn't work. I'm looking at infrastructure currently. I deployed in Europe Central, which is closest to me, so latency to the cluster would be lower. We do have some interesting features here. One thing is Kubernetes, which is hibernation. So if you look at hibernation, if you look at clusters, majority of them, especially the ones used in development, are wasting a lot of resources by running 24/7, which is completely unnecessary. So I mean, that one I've configured over the work days of the week to be booted up back at 8 and hibernated at 10. And this will be completely taken care of by the seed cluster there. So it will proactively go there and shut down all the nodes at 10 p.m. and we'll boot them up again tomorrow morning at 8. So that whenever I show up in the home office, then my cluster is there ready available for me. I can also schedule here maintenance windows. So all of our clusters are managed. So whenever operating system patches have to be pushed and so on, I can configure what is the time that fits to the purpose of that cluster. So if you think of different applications, industries, and so on, I mean, if you're in, let's say, manufacturing, then obviously your hot time is during the work week, so you don't want to have any instabilities throughout the week. Weekend is pretty much the time where you do all the maintenance. If you're in, let's say, retail and online shopping and so on, weekend is exactly the point of time where you don't want to have any instabilities because everybody else is at home browsing and shopping. So you would rather do that during the work time of the respective market region. You can reconcile cluster configuration as well. We can rotate kubeconfig keys and tokens, or I can just delete the cluster. Another pretty neat thing here is terminal access to the cluster. So as you can imagine, that one is running in a VPC, so it doesn't really stick out to the public internet. Therefore, from outside, I wouldn't be able to access it directly. But what I can do is I can open a web console directly into the cluster. So if I look into this one, the only thing that I deployed here is basically Redis, which is nicely running in a master and to slave mode. And otherwise, a part of that, it's pretty empty. This was pretty neat and pretty useful for many of the folks on our side that were testing and running stuff internally. Plus, it saved us from the challenge of having clusters shining out in internet, being then port scanned, vulnerability scanned, and so on. Completely unnecessary. Another thing that we have is we do have logging and monitoring. I mean, we deploy basically Grafana and Kibana instrumentation for every cluster. Grafana in that particular case is running in my cluster, so I don't have to do anything. It's automatically deployed in there, and I can look into the state of my control plane. So at the moment, it's obviously very idle. Not much is happening in there, except for a couple of requests here and there to the API server. And that's an out-of-the-box thing. So up to now, the only thing I did was I basically pressed the plus button. So how does that look like? If I want to create a new cluster, I go back to the clusters view, I click a plus. Coming back to this central point of control that we were talking before that. So first choice for me, obviously, switch infrastructure is that I want to run on this time. I could take AWS. I can give a meaningful name for me. I can select a version. At the moment, we do have .6 as a preview, and then the .4 as the default one, and all the other ones we technically code deprecated. So we do not encourage people to create clusters anymore there. Nevertheless, all the versions back to 1.15 are something which we support. So as I mentioned, we do have a long tail, and we cannot just pull the switch and shut them down, because there might be workloads that are still relevant there, and that's not up to us. Another thing is purpose here. So at the moment in the account that I have, I just have evaluation. Another thing that's interesting here is the secrets. I mean, I can either use that secret or I can add a new one. So this is as easy as basically going to AWS. I create a new API key for me, and then I add it in here, which essentially enables Gardener here on my behalf to go into an account and then start creating resources there. So create networks, create VMs, create whatever necessary. Region is something that you can select. Technically, we could deploy in any region. I mean, at the moment, EU Center is the most used one for us, because the majority of our development for the lower level infrastructure is Europe, but we do have as well workloads in Asia Pacific, in US. And so on networking, we currently support Cilium and Calico. Calico being the default, works pretty nice. Another interesting thing to mention here is Garden Linux. So as I mentioned, CoreOS disappearing was kind of a blow to everyone. So we had to figure out an alternative. We do have support for SUSE Ghost, and that works pretty nice. We do also have Ubuntu in here, but nevertheless, Garden Linux is essentially a minimum distribution there for the container OS, which we deploy on. It gives us a handle over, what features go in there, what's enabled, what's disabled. We can release patches pretty much instantaneously. It's just easy for us to manage when we get into the thousands of VMs, and that's why we did it. We did it that way. So if you look at Garden Linux, that sits on gardenlinux.io. It's also fully open source. It's completely out there. We do have flavors there for bare metal, for KVM, for AWS, and so on. So all the supported infrastructures. You might want to check it out going forward. It's a kind of a slot-in replacement there for CoreOS, as much as we care. Then you can select some standard add-ons that you can deploy, dashboard and nginx as ingress. And then the next thing that we push to people is basically the maintenance slots. So we want to know when is the point of time that a cluster is okay to be messed up with. And by default, it's like middle of the night, but this gives flexibility to people to specify that. And hibernation is also something that we enable by default. Many people simply don't think about it, and that's why having it on by default was the logical option. So we stop all the clusters at 5 p.m. normally. And if you want to kind of disable that, then you need to spend extra effort. Otherwise, by default, we're going to shut them down at 5. And then you're going to boot them up the next morning when you show up. If you want to have more complicated hibernation schedule, you can still do that. All of that results actually into something which is called cluster bomb, which is kind of a YAML file describing everything in that configuration. So if I go back to my clusters, and I don't want to create a new one, if I go back to my clusters, leave, yep. And if I look at the one in AWS, where Redis was deployed, it also has a cluster bomb, which has everything described in here in terms of the versions, the maintenance window, the workloads, the version of Kubernetes, the underlying OS, all the nodes that are deployed, all the pods that are deployed in here. So everything's in there. So in a sense, we can take that cluster bomb and transport it to another infrastructure, and it's going to work the exact same way. Because we do have the same version of Kubernetes there, the same Garden Linux in there, and we abstract away the underlying network and compute. Any questions so far?
This is
or we
great.
can do that.
We're starting to get towards the end of our meetup time.
Correct. I mean, I'm also at the end of my demo. So
Perfect.
then moving forward, the goal for us here being that we want to have this kind of multi-cluster kind of ops UI, which gives you a control over multiple clusters and gives you a chance to define all the different types of configuration that typically otherwise you would do by other means. So you have kind of a one bucket to throw that configuration in, which then works on any supported infrastructure that we add. So when we add support for the number 4 or 5 or whatever hyperscaler shows up there, that's gonna also work there too. So that's kind of the promise of Gardener. So the same Kubernetes experience everywhere. Everything there, everything in the project happens in GitHub. So if you go to github.com/Gardener, so that's where all the code is. The web console is in there. All the controllers for the different infrastructures are in there. So that's where people took it from, white labeled it, and then pushed it as a project on their own. Same for Garden Linux. I mean, it's sitting on gardenlinux.io. You can explore that. So yeah, my call to you is basically go there, take a look. If you're looking for a kind of a consistent, coherent control plane across infrastructures for Kubernetes, that works quite nicely and gives you a chance to do that on your terms. So without having any chains put on your hands. Having said that, that's all from my side. If you have any questions, feel free to reach out either to me or to Pavel, who is also in the call. Pavel is part of the Gardener team, so can also organize follow-ups or provide additional details. We're more than happy to hear, first of all, how that would fit to your needs, and then second, of course, support if you have questions.
Excellent. Looks great.
Yeah, awesome. Thank you, Krasimir and Pavel as well.